The last section of this chapter has to do with solving some trig equations. So we get to find some solutions. So we have to use our unit circle today to help us with some of these problems. Alright, so let's say they give us that sine x equals 1/2. You guys see that, or is that a bad glare for you guys? I got a glare up here, that's why. You guys good? Alright, yell at me if it's not. And we want to know, is pi over 6 a solution? So if we look at our unit circle, and we look at when sine is pi over 6, what's our sine value at pi over 6? One half, right? So do you think 1/2 is pi over 6 a solution for sine x equals 1/2? Yeah, it is. But do you think it's the only solution? No, it's not, right? Don't draw this out because you know how bad I am at drawing, like the sine graphs and all of those. If we think of that sine function, our sine function, we know it goes through the origin, right? And it kind of comes up and then it comes back down. Trying here, right? Oops. And then it comes back up, right? And then this kind of keeps going on, right? And it goes in both directions. And we were looking for when that value was at 1/2. So poops and giggles, like 1/2 would be right here. So that might be where our pi over 6 is. But are we at a half right here? And if we kept going, we're at a half here and a half here. And that keeps on going and going and going, depending on how many times you want to go around the circle, right? So we need to be able to also find how to find all of the solutions kind of going around in a circle. So if we think of if we want to find all of the solutions, we're looking for all of those solutions. Oops. When y equals 1/2, right? So now we have to think of that pi over 6, right? When that x will, or when we have that 1/2, and we're looking at that sine, like where does that happen? When sine of x equals 1/2. It's going to happen in 2 quadrants, right? Anybody know what 2 quadrants you're going to get where your sine is 1/2? 1 and 2. Oops. So in quadrant 1, oops, yeah. And then in quadrant 2. So in quadrant 1, that's the easy one. That was when our x equaled pi over 6, right? And we know that when it comes to our sine waves, they repeat every 2 pi, right? Going around the circle. So that period is 2 pi. Remember you guys' period, how to find a period? So if I want to find all of my solutions, it's going to be wherever I am at pi over 6, and then as I'm going around my circle, right, so at pi over 6, and then I'm going to go all the way around that circle, so I'm going to add another 2 pi to it, and then if I go around again, it's another 2 pi. So I got to add 2 pi, right, if I go around the circle once. But I might want to go around it twice, or I might want to go around 3 times or 4 times. So we just add an n to the end of it, and then that n is just how many rotations you're going around the circle. Right? But we also know that it happens in quadrant 2, right? So we just need to find our value for where it happens in quadrant 2. You can use your unit circle, right? Or if you think of your circle, oh boy. And we know that that sine, like at pi over 6, is kind of like right about there-ish, right? So we know that if it comes into quadrant 2, whoops, that's really bad. It's kind of like right about there-ish. So if we know that like this radian from here to here is pi over 6, you know, like on this other side it's going to be like pi over 6, right? But if I go halfway around the circle, I'm at pi, and then I gotta, oh my goodness, this thing is crazy. I gotta go to pi, but then come back that pi over 6. So it's on your unit circle, or you can try and do it mathematically. If I went halfway around the circle, you're at pi, but you gotta subtract that little piece, that pi over 6. How do you subtract fractions? Common denominator, right? So we're going to have what? 6 pi over 6 minus pi over 6, which is going to give us 5 pi over 6, right? If you look at your unit circle and you look in the second quadrant and you want to find where sine is 1/2, guess where it's at? 5 pi over 6, right? So I need to find all of my solutions. So I know that I'm at 5 pi over 6, but I could go around the circle. I could go around the circle once, right? Or I could go around the circle how many ever times I want. So I'm going to add that little n onto the end of it. Does that sort of make sense? It's like you know your answer's here, right? Then you're going to go 2 pi around and you're going to hit it again. You're going to go another 2 pi around and hit it again. Another 2 pi, hit it again. Not too shabby. Right, spice it up a little bit. There. Let's say we need to, sometimes I'll give it, instead of like finding art, so if they want you to find all of the solutions, you know that you're going to be adding that little n onto the end of it, right? Because they don't tell you how many times they want you to go around the circle. Sometimes they'll give you like a parameter and they'll like find all of the solutions from like 0 to 2 pi. So they just want you to find all the solutions if you went around the circle once, right? So let's say they wanted you to solve the equation on the interval from 0 to 2 pi. But let's try a cosine. And instead of just an x, let's say they give us a double angle, so they give us cosine of 2x. And they want to know when that equals the square root of 2 over 2. So now we have to think of which quadrants is our cosine going to give us square root of 2 over 2. Where's that going to happen? 1 and 4. Yep. So we got to find our solutions for quadrant 1. And we got to find our solutions in quadrant 4. So on our double angles, we have that 2x. So instead of just an x, we got to make sure we keep our little 2. So we have our 2x. And what's the radian for cosine at square root of 2 over 2? And if you have to, you can flip that into degrees to figure out your radians. Anybody?
Or not a quadrant one. But, or pi over 4.
Which one is it?
Pi over 4.
Pi over 4 for quadrant 1? Yep, yep. So we know then that our 2x equals our pi over 4, right? And then we're going to add onto that 2 pi n. So now we got to solve it for, oh, you want to solve
No, we
it
have to find for all our, no.
Yeah. Do we want to solve it for x in quadrant 1, or do you want to write the equation for quadrant 4?
Quadrant 4.
Write that one. That's fine. Yep. So kind of the same thing. We got our 2x equals. So when does our, in quadrant 4, what's our value? Our radian for square root of 2 over 2?
7 pi over 4.
Yep. 7 pi over 4 plus 2 pi. And we don't know how many times we can go around yet. So we need to solve it for x. So let's go back to quadrant 1. Okay. How are we going to solve this guy for x? What do we got to do? How do you get x all by itself?
Divide the whole thing by 2.
Divide the whole thing by 2. Yeah. Okay, so if I divide this side by 2, I got to divide this side by 2. Okay. 2's are going to cancel. X equals, and then if it helps, write these separately, right? So we have pi over 4 divided by 2, right? Plus 2 pi n divided by 2. So what's pi over 4 divided by 2? What do you got to do?
Copy dot flip.
Multiply by that reciprocal. Yep, and what do we get? Pi over 8.
Yep.
Right. Plus, what happens on the right?
Don't the 2's cancel?
Yep, and you have
Pi.
pi times n, right? We want to do the same thing for quad 4.
Yeah.
Yep, so we're going to divide by 2, divide by 2. X equals, what are we going to get? 7 pi over 8 plus pi times n. We good with all those?
Yeah.
All right. So on this one, they want us to stay on that interval 0 to 2 pi. So we got to put in some values for n until we get up to close to without going over a value of 2 pi, right? So we love our whole numbers. So we're going to start like when n equals 0. So we haven't gone all the way around the circle. So we're going to put 0 in for n. And if I put in 0 for n, what am I going to end up with?
Just pi.
Yeah, pi over 8 times pi times 0. That's going to give me pi over 8. Is pi over 8 between 0 and 2 pi? Yeah. Yep. So we know we cannot like start going around the circle. What about when n equals 1? That would be going all the way around the circle. So what do we got? Pi over 8 plus, if I plug in 1, I get pi. Right? Oops, let me squeeze this up for you guys. If anything, we got to add those little fractions together. So this would be the same thing as like 8 pi over 8. So that's going to give us 9 pi over 8. Is 9 pi over 8 between 0 and 2 pi? Yeah. Yep, so we have to keep going. What about for n equals 2? So that'd be pi over 8 plus 2 pi times, oops, yeah. if we need to get our common denominator, pi over 8 plus, what are we going to get? 16 pi over 8?
Yep.
Yep. When we add those together, we get
17 pi over 8.
17 pi over 8. Is 17 pi over 8 between 0 and 2 pi? No, it's over it, right? So we can't include, yep. So that's telling us we can't include that one. So our solutions would be that pi over 8 and then that 9 pi over 8. You can always kind of cheat a little bit, because like once we got there to where when we put in the 2 and we got 2 pi, we know we can't be over 2 pi, and I'm adding something to it, so it's going to automatically tell me I'm going to be over 2 pi, right? So then now we just need to do it for those values in that fourth quadrant. So we're going to start when n equals 0. So 7 pi over 8 plus 0 times pi. 7 pi over 8. Is that less than 2 pi, or is that between 0 and 2 pi? Yeah, so there's a solution. And then we're going to plug in n equals 1. So 7 pi over 8 plus pi. But you got to have a common denominator, so that's going to be 8 over 8, right? So that's going to give me 15 pi over 8. Is 15 pi over 8 less than 2 pi? Yep. So we know that's a solution. What do you think is going to happen when we do n equals 2?
It's going to be over.
It's going to be over, right? Because we are 1/8 of a pi away from there, right? So then now we found all of our solutions between 0 and 2 pi. Yeah. Crazy, crazy. Then they can get really crazy on you guys. Want to try one more? I guess, exactly. These are the fun ones. I like these ones. Alright, let's find all those solutions again. You'll like this one. Alright, so let's say we have 3 sine of x minus 2 equals 5 sine of x minus 1. So our goal is to find out what our x is, right? So our x is with that sign, so we want to get like our signs on one side and our whole numbers on the next side, right? So start by looking, you got 3 signs and you got 5 signs. So we can either subtract 3 signs from both sides, or we can subtract 5 signs from both sides.
Subtract 3 signs.
Absolutely. Look at you guys. You're on fire. Absolutely. So, yep. So subtract 3 sine of x from both sides. These guys are going to cancel. So we get negative 2 equals how many signs?
2 sine x.
2 sine x. And then don't lose your little negative 1, right? And what do you think you're going to do?
Add 1 on the other side.
Add 1 to the other side. Add 1 to both sides. We get what? Negative 1 equals 2 sine of x. Yeah. Is sine all by itself yet?
No.
What do you think you gotta do?
Another 2.
Divide by 2. Divide both sides by 2. Negative 1/2 equals sine of x. So now we're kind of right back to where we were just a few moments ago. We got to think of that sine equaling negative 1/2. I bet you it's going to happen in 2 separate quadrants, right? Which 2 quadrants do you think it's going to happen in?
3 and 4.
3 and 4?
1 and 2.
Ooh.
Well, negative. Oh, it's negative.
It's negative, so it's going to be in
Yeah, good work.
3 and 4. Yep.
And this week.
You're right. Yeah, exactly. So quad 3. Oh, we'll just do it underneath. And then quad 4. Right? So in quadrant 3, it happens at
7
pi over 6, right? Yep. Oops. E6, there we go. And in quadrant 4, it happens in 11 pi over 6. Yep. And then they want us to find all solutions. So do we know how many times we're going to go around the circle? Nope, because they want all of them. We know that our sine and our cosine, they repeat every 2 pi, right? And then we just don't know how many times we want to go around the circle. So same thing on quadrant 4. We know it's going to repeat every time we go around the circle, every 2 pi. And then our n for how many ever times we're going around the circle. And you got your 2 solutions. Well, all solutions, sorry, for those 2 quadrants. And that's it.
I don't gotta do that. And you go to 0.
No, because they didn't give you an interval, because they wanted you to find all of the solutions. So if they want all of the solutions, you're always going to end with that n. But if they give you a certain interval, like they wanted it between that 0 and 2 pi, then that's when you're going to start plugging in those values for n to figure out.